In this video, we will understand the operating principle of a residual current device or RCD. Ready? Let us begin. To understand how a residual current device works, we must first understand the basic rule on which it operates. The operation of a residual current device is based on one simple rule. The vector sum of currents in all active conductors must be zero. As long as this condition is satisfied, the circuit is considered healthy. When this condition is no longer satisfied, the device trips. So, let us see how a residual current device checks this condition in practice. Inside every residual current device, there is a magnetic toroid with a secondary winding. This magnetic toroid surrounds all active conductors supplying the circuit. These include the phase conductors and the neutral conductor, if present. At this point, it is important to note one thing. Protective conductors do not pass through the toroid. With this internal arrangement in mind, let us now look at how currents behave under normal conditions. Consider a single-phase circuit. The current flowing from the source to the load is denoted as I1. The current returning from the load to the source through the neutral is denoted as I2. By convention, I1 is considered positive. I2 is considered negative. Because the same current leaves the source and returns to it, the vector sum of I1 and I2 is zero. When the vector sum is zero, no net magnetic flux is produced in the toroid. As a result, no voltage is induced in the secondary winding. No current flows in the tripping circuit. Under these conditions, the residual current device remains closed. Now let us see what changes when a fault occurs. Consider the case of an earth leakage fault. A fault current flows from the source. It passes through the magnetic toroid. It then flows into exposed conductive part through insulation failure. However, this fault current does not return through the neutral conductor. Instead, it returns through protective conductors in a TN earthing system. Or it returns through the earth itself in a TT earthing system. Because part of the current takes a different return path, the current balance is disturbed. The vector sum of I1 and I2 is no longer zero. This difference in current is known as residual current. The presence of residual current produces an alternating magnetic flux in the toroid. Due to this alternating magnetic flux, an electromotive force is induced in the secondary winding. As a result, a current, denoted as I delta, flows through the tripping control circuit. If the residual current, I delta, exceeds the rated sensitivity of the residual current device, the tripping mechanism is activated. The associated switch or circuit breaker opens. The circuit is disconnected. And supply is cut off automatically. This automatic disconnection is what protects people from electric shock. Residual current devices are provided with an important feature that we must know about. Every residual current device is provided with a test button. The test button is not an optional feature. It is a safety function. The purpose of the test button is to confirm that the RCD is healthy and operational. When the test button is pressed, an internal test circuit creates an intentional imbalance of current. This intentional imbalance simulates a residual current inside the device. If the RCD is healthy, this simulated residual current will cause the device to trip immediately. This confirms that the sensing mechanism and the tripping mechanism are both operational. Because the protection of people depends on this function, the test button must be operated regularly. In most installations, it is recommended to operate the test button at least once every month. This simple action ensures that the RCD will trip when it is required to trip. If the RCD fails to operate during the test, it can no longer be relied upon, and people are at serious risk. In such a case, the RCD must be repaired or replaced immediately. In the next video, we will look at the operating characteristics of residual current devices. Thanks for watching.